And the last section for graphing is exponential functions. Exponential functions are functions in which the base of an exponential expression is a number and the exponent is a variable. In this particular exponential function, the x inside of the exponent is divided by 2. So it would be in our best interest to try to use some multiples of 2. So let's use, for instance, -2, 0, 2, 4, 6. Let's see what happens. When we use -2, we get 3 to the -1, which is 1/3. We can graph that one. It's not an integer point, but we can surely graph it. When x is 0, we get 0 divided by 2 is 0, 3 to the 0 is 1. When x is 2, we get 3 raised to the 1 power, which is 3. When x is 4, we get 3 raised to the 2 power, which is 9. And when x is 6, we get 3 raised to the 3 power, which is 27. We can't graph that one. Now, if we were to go in the opposite direction, if we were to plug in, for instance, -4, that would give us 3 to the -2, which is 1/9. And what we'll see is that the y values will continue to get smaller and smaller and smaller, but they're never going to be negative. So that graph is going to slide very, very close to the x-axis on that left side. That's what we call asymptotic behavior. When the asymptote is the x-axis, that is the line that the graph is getting closer to, then we don't actually have to graph it. But we'll see in the next example that we'll have an asymptote that's a different line other than the x-axis. So for this one, doesn't appear that there's any operations happening to x before we use it as an exponent. So let's just go ahead and plug in some whole numbers. Let's use -1, for instance, 0, 1, 2, 3, and see what that does. So 3 minus, and then 2 raised to the -1 power would be 1/2, so that's going to be 2.5. So I'm going to graph the point -1, comma, 2.5. And then 0, comma, 2 to the 0 is going to be 1, so that's going to give it 2. So 0, comma, 2. When we plug in 1 for x, that's 2 to the 1, which is 2. That's going to give us 1. When we plug in 2, we get 3 minus 2 squared, or 3 minus 4 is -1. When we plug in 3, we get 3 minus 2 cubed, which is 8. So 3 minus 8 is -5. And then I think we can see that the next one is going to give us something that's going to be off of the graph. So we'll graph 3, comma, -5 as our next point. And then let's go in the other direction. Okay, so what if x is -2? Then we'd have 3 minus 1/4, which would be 2 3/4. And so our graph is actually going to get much, much closer to having a y value of 3. So it's going to get very close, but it's not going to go beyond y equal to 3. Very steep over there on the right-hand side. For this one, since we do have an asymptote to the graph, I'm going to dash in a horizontal line to represent that asymptote. Let's do one more example. This one is y equals 2 to the x minus 4. This is going to be similar. So let's use a couple of negatives and some positives. And let's see what happens. 2 to the x minus 4. So 2 to the -2 is 1/4, minus 4 is -3 3/4. So -2, comma, -3 3/4. That's almost -4. And then when we plug in -1, we'll get 1/2 minus 4, which is -3.5. So -1, comma, -3.5. 0, 2 to the 0 is 1, minus 4 is -3. And 2 to the 1 minus 4 is 2 minus 4 is negative 2. And 2 squared minus 4 is 4 minus 4, which is 0. And 2 cubed minus 4 is 8 minus 4, which is 4. And so that ought to give us a pretty good idea of what that graph looks like. It's going to go very close to this horizontal line on the left side and then going to get very steep on the right side. I'm going to go ahead and put a little dashed line in there for that horizontal asymptote. And that's it.